supportive community of innovation and innovators around the university and around the kingdom. One form is to organize webinars to enrich the young minds with the information they need to learn and grow their innovations. Our webinar for today is about renewable energy and the fuel cell electric vehicles, which is a very interesting and a very wide topic, to be honest. It will be presented by Dr. Wael Ahmed Fouad. Dr. Wael received his PhD in chemical engineering from Rice University in Texas, the United States. And now he is an assistant professor in the chemical engineering department here in KFUPM. Dr. Wael is also teaching courses in the new concentration programs of renewable energy and storage. If any of KFUPM students here are interested to take these courses with Dr. Wael. Dr. Wael also published more than 30 articles, mostly related to the field of renewable energy and hydrogen fuel, which makes him a perfect fit for our webinar today. Welcome you, Dr. Wael.
Thank you so much. Thank you for the invitation, and I'm really happy to present today about this topic.
Well, it's an honor to have you here, Dr. Wael.
Thank you. Okay, shall we start?
Yeah, just to remind everyone, we will start now, and I will be receiving your questions through the chat box here. You can write your question, and in the end of our webinar today, we will dedicate like 10 minutes to answer your questions by Dr. Wael. Or if you wish, you can raise your hand at the end of this webinar, and we will give you the mic. The floor is yours, Dr. Wael.
Okay. Thank you so much. I hope this presentation is interesting to many of you, or would be interesting to many of you. At least opens new ideas and generates some good discussion. I'll try to make the presentation within like 30 minutes, as much as possible, but no guarantees. So, but definitely less than 40 minutes. For those who attend the renewable energy concentration, as well as the hydrogen mobility concentration, which I also teach in and I'm responsible for, then a lot of what we're going to discuss today isn't really, wouldn't be really new for you. But for others, I hope that this would be some exciting information and knowledge that maybe would get you interested into the topic and maybe join the concentration in the future. Okay, so really let's start. So renewable energy and hydrogen fuel cells, fine. And usually when people talk about renewable energy and hydrogen fuel cells, usually the first thing they talk about is global warming. And this is why we need renewable energy, because basically the temperature of the universe is steadily increasing, and with how we are so far, or with our current policies, we can basically hit a 1.5 degrees Celsius increase in our climate temperature by 2040. This should have been our aim for 2100 in 80 years. But actually the current pattern shows that we're gonna increase the climate temperature by 1.5 degrees Celsius just in 20 years. So basically we're doing very bad regarding global warming and CO2 emissions. And basically here I just shows the most horrible picture that I can find in the internet to show to you how horrible fossil fuels are and how refineries and power plants are really catastrophic. And as we all know, global warming, if things continued this way and we didn't act rapidly and efficiently, this will lead to a lot of forest fires, which are already happening, drought, hurricanes, and a lot of more of disasters that eventually will cause a human catastrophe. So we all know this, and that's the first thing people would talk about. So there is no new information here. This is why I don't really concentrate on this. And people who talk about the environmental effects of fossil fuels and hydrocarbons would actually give you this piece of information that, look, what did COVID-19, how did COVID-19 actually positively impacted the environment in China? So this picture was taken by the satellite in January the 1st, 2020. So just when COVID-19 was starting up. And you can see here this yellow cloud is basically how much the air in Beijing and around Beijing suburbs is polluting. And just 1 month later, after COVID-19, when all people were forced to stay home and all industries and factories stopped working, suddenly the climate in China was clear and was nice. Everything returned just like how Mother Nature started. So people, environmentalists especially, would argue that, look how when we were committed to the environmental problem, or forced to commit to the environmental problem because we stayed home, how in just 1 month, the climate was a little bit saved, and there was a big difference. So, so really, why not just take action and start solving our problems? If just 1 month of an effect did such a huge and significant positive impact on the climate. And what also environmentalists would argue about, that the solution to save our environment from the global warming disaster is basically to use renewable energy. So CO2 emissions as currently is basically this yellow, thick yellow line. And with the current policies and the current strategies, we are hitting a constant or a plateau in CO2 emissions of 35 gigatons of CO2 per year. And the current policies hope to keep this actually constant, this level of CO2 emissions constant. But this level of CO2 emissions is by itself catastrophic. So what environmentalists argue is that, and they correctly argue, that actually one way to decrease the CO2 emissions from this yellow curve down to this green line, so from 35 gigaton per year down to around 10 gigaton per year of CO2, would be actually to use renewable energy. And the renewable energy would be used to electrify and power buildings, transport, provide heat, and so on, for different sectors and different industries and so on. So basically we can replace around 25 gigaton per year of CO2 just by converting everything to renewable energy, which is good and it's correct, no doubt in this. The problem is that always energy transitions require a lot of investment and a lot of money. So it's way easier to just go with the oil flow. It's very easy to give you statistics about how fossil fuels are horrible and how they damage the environment, and that we need to act against that, and everyone knows this. The problem is that our financial budgets are different than our environmental budgets. We know that we need to act in 20 to 30 years to solve the global warming problem in 20 to 30 years. The problem is we don't have the money needed, or no one is motivated to invest billions and billions of dollars in just few years to save the environment. This is not enough business motivation, unfortunately. So a lot of countries would just prefer going with the flow and keep things as they are. So this is not, CO2 emissions is not a good motivation, unfortunately. So how about we look at the problem from a different perspective? Maybe that would provide another motivation for people to act immediately and start the transition to renewable energy. So let's, for example, take the case of Saudi Arabia, and let's consider the case of Aramco. Actually, interestingly, Aramco published last year, for the sake of their IPO project, an approximation of Saudi Arabia's oil reserves. So here in Aramco's official IPO report, they reported the oil reserves and the biggest oil fields in Saudi Arabia, including Ghawar, which is the biggest onshore oil field, Khurais, Shaiba, and others. So basically, if you summed up how, or when Aramco summed up their approximate oil reserves, they found out that Saudi Arabia has around 256 billion barrels of oil that is reserved under the ground in total. So fine. So how is that related to the current situation? Actually, if you forecasted the oil production for Saudi Arabia in the next 100 years, you will find that basically this is the green curve is the oil production from Saudi Arabia per day. So this is actually a little bit outdated. When this graph was developed, it was when last year when Saudi Arabia was producing around 10 to 11 million barrels per day. Now, due to coronavirus, it decreased a little bit to around 8 million barrels per day. But in any case, so the green curve is Saudi Arabia's average oil production. The purple curve is actually Ghawar field's oil production. And you can see that starting from around 2008, 2010, Ghawar field started depleting, and the number of barrels, crude oil barrels that were extracting from Ghawar field is steadily decreasing with time. But still, the crude oil production is doing fine with new explorations and so on, with investment really. But we expect that, depending whether you think that the current oil reserves is 250 billion barrels or 350 billion barrels in the best case scenario, that, for example, this curve is the 250 billion barrels. Basically, we have enough oil to get us along 100 years more. This is the point here. So we have a lot of oil, alhamdulillah, but we will be in good shape in 100 years. So CO2 emissions require a lot of money. Our oil reserves are good. So there is no any shortage of energy. Then why should we transfer to renewable energy? Right now, there is no any motivation that you can give to investors. However, there is one motivation. And COVID-19 actually taught us a very basic but important lesson in economics. You remember in April and in March, the West Texas Index oil price went down to around minus $40 per barrel. This means that actually you buy a barrel and the company will give you $40 above that barrel for free, just to remove this crude oil barrel. No one wanted this crude oil barrel, okay? That the price sunk down to minus $40. So what this tells us is that it doesn't matter how much crude oil you have reserved if there was no demand. So supply makes sense and is important only if there is demand. If there is no demand, then your supply is useless, okay, is worthless actually. طيب. Then based on this, let's look on how will be the oil, the energy demand in the coming, not 50 years, no, in the coming 10 years, which is nothing in nation's history. This is nothing. What actually the biggest energy organizations and research centers predict is that in 2030, 60% of East Asia, which are our main buyers, our main customers for Saudi Arabian oil, will shift by 60% to renewable energy. The European Union will depend by 55% on renewable energy. Latin America by 85%, North America, Canada, and the US by 60%. What this basically tells you is that the number of customers and the demand for Middle East oil will rapidly decrease in the next 10 years, rapidly. The remaining 40% here and there are not for oil. The remaining demand will be for natural gas and not for crude oil. So in the best case scenario, in 10 years, the demand for oil will remain as it is with 0% increase or decrease. But in the worst case scenario, the demand for crude oil will sharply decrease and drop by 30%. Now, this is a good motivation for transition. Now we're talking business. Okay. So basically, in my opinion, the main motivation for renewable energy transition shouldn't be environment, even though it would be nice to save the environment. It shouldn't be anything else other than pure money. So if you want to keep your energy industry and you want to keep your economy as strong as it is advisable to start your transition from now. And this is actually partly why the government in Saudi Arabia decided to start up NEOM. And the whole idea about NEOM, or part of NEOM's idea, is basically to build a 100% renewable energy system that would basically produce green hydrogen. We're going to discuss later what green hydrogen would do for you. And basically the term green hydrogen basically means that this hydrogen is produced from renewable energy. So you would use renewable energy to power and electrify your cities and industry, as well as to produce hydrogen. Not only that, already 3 years ago, the government, as part of Vision 2030, started up what's called the National Renewable Energy Program. And the National Renewable Energy Program role is actually to oversee all renewable energy projects in Saudi Arabia. And its main goal is to produce 10% of the kingdom's energy consumption through your renewable energy in 10 years. So 10% in 10 years. And this includes several projects that already started and will start, like Al Khafji Solar Desalination Power Plant. This is the largest solar desalination power plant in the world. Skaka Solar Power Plant, this is in Al Jawf, it's already operating, and it produces 300 megawatts of electricity from solar. Domat Al Jandal Wind Farm, it will start in 2022. Surprisingly, it's funded by Saudi Aramco. And it will produce 400 megawatts of renewable energy. And there are already currently tenders to produce extra 2 more solar power plants. and more are coming in the pipeline. So actually, what this shows you is that, or I hope that it shows you that alhamdulillah, the kingdom realizes the danger in fully depending on crude oil, not because the reserves are low, rather because the customers, our customers, are depleting. It's not our oil reserves that are depleting, really, it's our customers. And this requires us to move on. Okay, and sometimes in life you just need to move on. So, and that's what the government is trying to do gradually. And there are a lot of projects going on. Okay, fine. So, fine, we're gonna move on to renewable energy. Everything sounds good and everything sounds perfect. Well, not that perfect. The problem is that if we considered a case in the US, let's say California state, where actually in California state, they depend by around 30 to 40% on solar energy for electricity production. So actually this is a good case to study. And in California, they noticed what's called the duck curve. And the duck curve actually tells you the following, that at night, when there is no sun, so you don't have solar energy anymore, and you depend on your main grid, which is natural gas, to produce energy, you get such a curve. But then at around 6 to 8 a.m., when now sun rises and you start getting some sun, and solar panels start working and functioning, producing electricity, you get a big decrease in electricity demand from your natural gas power plants. Okay, from your natural gas power plants. This decrease is because basically everyone is depending on solar energy. So no one needs natural gas anymore. But then as sun sets, so around Maghrib, then solar panels don't work anymore, and you get a big increase in natural gas demand within around 3 hours. So in 3 hours, you get around 14 gigawatt of energy demand from natural gas. 14 gigawatt. This is a huge number that no power plant can handle well, especially old power plants. They are not that dynamic to produce to you 400 gigawatt in 3 hours. Okay? And this causes a lot of problems to power plants. It damages power plants. It's not good business at all. And it causes a lot of problems, basically. So this is the duck curve. And basically, this is how the curve looked at 2012. And this is how the curve looked at 2017. So you can see that as years pass and as people install more and more solar panels and the renewable energy penetration to the national grid increases, this drop in natural gas demand during daytime, during the morning and the afternoon, will increase. And the number of gigawatts that is required for power plants to produce in just 3 hours will increase with time. It will increase with time. And at some point, power plants will not be able to maintain such demand anymore. Okay, so if such problem happens when we use renewable energy, what to do? And basically, the solution to this problem is to use what's called energy storage. And energy storage, the concept behind energy storage is actually simple. You store energy, you store your excess energy at night when everyone is sleeping, no one is using a lot of electricity, you store that excess electricity in some form. And in the late afternoon or the early night, when the demand for natural gas jumps, you release whatever energy that you stored. Now we are not talking yet about how to store energy. We're just saying that if such a technology exists, okay, that would be very helpful to solve the duck curve problem, which will always happen to you, whether you are in California or in Saudi Arabia. Okay, so you store the excess electricity at night, at late night, when everyone's sleeping, and you release it at early Maghrib, early night, when the demand for natural gas jumps rapidly. So this is the idea of energy storage. And what we are hoping for after installing solar panels and installing energy storage technologies and cooperating this, or integrating this really with our natural gas main grid, that we would reach to something that's called a smart hybrid power grid. And in your smart grid, you would basically depend big time on renewable energy resources like wind energy, solar energy, nuclear energy, and so on, in addition to your energy storage technology. And all of that would be connected through a smart, artificially intelligent system that would depend on the Internet of Things. And that center intelligent system would basically predict for you how much demand is for power and for electricity across the day, and using some smart meters that are found in our smart homes and our smart buildings and our smart industries. So they would send that center that, oh, today we need 30 megawatt of electricity. And that artificially intelligent center would send back or transmit back this data to our renewable energy power plants, so that they would produce as much electricity that you want, and they would send it back to you. So it's really a two-dialogue system where you tell us how much electricity you need, and we will also predict how much electricity you need based on your history. We will also check the weather to see how much sunlight we have today, how much wind we have today, and based on weather forecast and based on internet data and so on, that center will send back that information to our power plants, and it will tell them that, you know what, the wind today is not that strong, so we will not depend on wind energy. The sun is good, so let's, for example, generate 80% of this 30 megawatt out of solar, 10% out of wind, and 10% out of, I don't know, nuclear energy. And send these 30 megawatts of mixed energy sources to our customer. Okay, so it's really a very smart system. There is only one problem with this system, as usual. There is always a problem. The problem is that to install such a system, the US Department of Energy predicted that the US would require $800 billion. No one has such money, no one. Okay. And installing different sources of energy, like solar, wind, natural gas, crude oil, nuclear, and as well as energy storage, without connecting all of these sources in a smart, artificially intelligent system, is a mess, gonna be a mess. You cannot do this. You need a system to connect everything together, but it's too expensive. So what to do? So here is what to do. One of the solutions is to use what's called the hydrogen economy. And the idea behind the hydrogen economy is to use renewable energy to produce hydrogen. Okay. And instead of extending long transmission and distribution lines, which are super expensive to build, and they require a lot of time to build, you would rather transport this hydrogen that you produced using renewable energy in the form of compressed hydrogen with trucks, or in the form of liquid hydrogen and pipelines, or you can convert this hydrogen into some chemicals like ammonia or methanol or cyclohexane, and transport these chemicals or these compressed hydrogens and liquid hydrogens through trucks or pipelines or ships to your destination. And at the destination, you would use them as a feedstock for the chemical industry, or you would use them to generate power at your site, or you would use them for mobility. And that's what we're going to talk about later. So really, hydrogen in this case acts as a source of energy, is produced from a renewable energy, so it's clean. It acts as a source of energy for power generation. It acts as a feedstock for our chemical industry, and it can be stored. Actually, Saudi Arabia is one of the biggest ammonia and methanol producers in the world. You can store ammonia easily, you can store methanol easily, and whenever you need extra energy, you can use the stored energy that you have. So you can convert ammonia or methanol back into hydrogen and use it for power generation. Or you can store hydrogen in the form of liquid hydrogen, and I don't know, at Maghrib or early night when you need extra electricity, you can use this hydrogen to generate power, and so on. So basically, hydrogen solves all of our, or most of our challenging renewable energy problems. And it's cheaper. It's relatively a cheaper solution for our problem. Okay, so now you would wonder, okay, but how expensive it is to produce hydrogen from renewable energy? And actually the answer is, if you would have asked me this question 5 years ago, I would have told you extremely expensive. 5 years ago, only 5 years ago, the cost of producing hydrogen from renewable energy was around 9 to 10 euros per kilogram of hydrogen. This is extremely expensive. Just in 5 years, the cost of producing hydrogen dropped by 45%. 45%. The expectation is that in 2030, the cost of hydrogen production will drop by another 50%. So really, it's gonna be by 2030 around 2 euros to produce 2 euros per kilogram of hydrogen, and this is so cheap, so cheap. So with time, it wouldn't be that expensive actually to produce hydrogen from renewable energy. So this is one good point. The other good point about hydrogen is that actually you can use hydrogen for CO2 conversion. So we are talking about global warming and CO2 emissions and how bad they are. طيب, everyone talks about CO2 capture. There's very little talk about after we capture the CO2, what will we do with it? Let's say that the oil price is so low that we don't care about enhanced oil recovery anymore. What to do with this hydrogen? Actually, the best thing to do with this hydrogen, and the easiest, is to actually react hydrogen with the CO2, is to react hydrogen with CO2 to produce chemicals. So you can react hydrogen with CO2 to produce methane, you can produce methanol, you can produce urea. If you reacted hydrogen with ammonia, it can be used as a feedstock for polymers, and so on. So really, it is hydrogen is not only a good energy storage material, it's not only used for power generation, it's also a good chemical to convert CO2. into useful products. And this is one way to save the atmosphere and to fight global warming. Hydrogen is a very important feedstock for ammonia production, which is the chemical that is most produced in the world, and for producing methanol, which is the second most produced chemical in the world. So these two, ammonia and methanol, both of them are produced from hydrogen, and both of them are sold in millions of tons per year. And you can see that actually the expectation is that the production of ammonia will steadily increase in the next 30 years, as well as methanol. So there is demand for ammonia and methanol, there is demand for hydrogen, so why not use hydrogen? It is good for the business. And actually, this is what people in NEOM thought about. So the whole idea about NEOM energy is actually to use renewable energy, wind and solar, to produce hydrogen, green hydrogen, use this hydrogen to produce ammonia, export part of the ammonia to Asia or to Europe, and then the remaining part would be transported to the cities like to Riyadh or Sharjah or whatever. And in the cities, ammonia would be reconverted back into hydrogen and used for transportation. And this is what we call hydrogen mobility. So now, what does hydrogen mobility mean? And hydrogen mobility, basically, in hydrogen mobility, the following. At point one, you basically pump hydrogen into your car, and it recombines with air that is going into your car from the atmosphere as the car moves, and hydrogen at 1 and air at 2 would be combined at 3, which is our hydrogen fuel cell. And the hydrogen fuel cell would produce for you electricity that would basically run your electric motor in the car, and your car would move. So it's a very easy and simple concept, actually. And this is why it's called fuel cell electric vehicles. So the point here is now, what is a fuel cell? And a fuel cell, you can think about a fuel cell as being a small factory to produce electric power, or a small power plant, where actually instead of burning hydrogen to produce steam, we don't do this. This is a highly exothermic reaction. If you did this in your car will blow up in seconds. Okay? Hydrogen is extremely flammable. Instead, what a fuel cell does safely is that in a fuel cell, you break down your hydrogen into protons, 2 protons and 2 electrons, and then somehow these 2 protons and 2 electrons will react with oxygen to produce water. And splitting the combustion reaction into 2 halves, which is what a fuel cell does, would generate for you electric power, and it is less exothermic, it's way safer, and more efficient. So how a typical fuel cell looks like is something along these lines. So you have an anode and you have a cathode, and at the anode you inject hydrogen, at the cathode you inject oxygen, and these electrodes are coated with catalyst, platinum catalyst, which is super expensive, okay? And that platinum catalyst would actually dissociate your hydrogen into 2 protons and 2 electrons. The protons will pass through what's called an electrolyte to reach to the cathode, while the electrons will pass through the electric circuit. This is how we generate electricity, and the electricity generated through the flow of electrons will power our electric motor of the car, and everything will now combine at the cathode to produce water. So it's a very simple, actually, process. And the main difference between fuel cells, solar cells, and batteries is that solar cells and fuel cells are basically what's called an open system. You feed them with fuel, and for solar cells, the fuel is light, sunlight. For fuel cells, the fuel is hydrogen. And as long as you provide them with fuel, whether it's sunlight or hydrogen, they will produce for you electricity. While a battery is different. A battery is a closed system. So you first charge your battery, and then you use that battery to generate electricity. Okay, so this is more of a closed system. A battery will not work if there was no charge that was initially stored in it. Okay. So let's go into another point. We talked about hydrogen, its importance, how it's critical for renewable energy and smart grids and so on, and what NEOM wants to do. And we a little bit explained fuel cells and how fuel cell cars work. But what would immediately, I guess, come to your mind, speaking about electric vehicles, is how does fuel cell electric vehicles compare to battery electric vehicles, something like Tesla. And actually, I don't want to go into a lot of details here, but basically this graph plots to you what's called the gravimetric power density and the volumetric power density. And you can see that lithium-ion batteries, which are used in Tesla and in electric cars, have a higher volumetric power density, while fuel cell cars have a bigger gravimetric power density. And in simple terms, what this tells you is that if you want both cars, a fuel cell car and a battery car, to basically generate for you the same amount of electricity, the battery electric vehicle will be smaller in size, while the fuel cell electric vehicle will be lighter in weight. Okay, so this is the difference. Fuel cell cars are lighter, battery cars are smaller and more compact. This is the reason why actually battery electric vehicles are very good for sedan cars. Sedan cars are small, so you need a battery, they're good. While fuel cell electric vehicles are good for big cars, buses, SUVs, trucks, and so on. Something with a lot of space, because they require space, but they are light, but they require space. So let's compare two fuel cell cars, two cars. Let's compare the Toyota Mirai, which is a fuel cell electric vehicle, to Tesla, which is a battery electric vehicle. Okay? And in this chart, let's consider only the standard models. I'm not comparing here the long range or the performance version of Tesla. I'm comparing what's called the standard Tesla version against the Toyota Mirai. This is more of a fair comparison. Okay, and actually the most popular Tesla model is Model 3. This is the most popular and in the streets globally. So let's basically just focus on comparing the Mirai to Tesla Model 3. And you can see actually that the Tesla Model 3 is not just cheaper, it's by around 40,000, while the Toyota Mirai is by 60,000. Actually, the Tesla Model 3 is better also in performance. So with the Model 3, you can have up to around 220 horsepower, while with which is like equivalent to like Mercedes-Benz C-Class. While at Toyota Mirai, you would produce something in the range of around 140 to 150 horsepower, which is like an equivalent to a Corolla. So fine, but there is another face to this coin. The other important piece is that if you compared both cars, but now in terms of mileage, So how long can you drive both cars without charging them? The Model 3 can drive a maximum of 220 miles. This is assuming that you are driving at 800 kilometers per hour, at 80 kilometers per hour, I'm sorry. Okay? So if you are driving at 80 kilometers per hour, maximum you can do 200 miles. While the Toyota Mirai can go up to 300 miles without charging it with hydrogen. This is a very important difference, and it is something that is advantage for fuel cell electric vehicles. You can see that actually the Tesla Model S, which is the top best model in Tesla cars, again the standard version, doesn't even do 300 miles. Doesn't even do 300 miles. And it costs double that of the Toyota Mirai. Of course, the performance is better in terms of horsepower, but it doesn't even do 300 miles. And again, these numbers are assuming that you are running at 80 kilometers per hour. The faster you run, the lower the mileages will be. So fuel cell electric vehicles, in conclusion, are good for long distances travel, and they are good for big cars like buses, trucks, and so on. This is actually why, surprisingly, the first ever fuel cell was actually used in 1969 in NASA's Apollo 11 mission to the moon. People think that fuel cells are new technology and they are super new. Actually, no, we knew about fuel cells more than 100 years ago. They were just too expensive to use. And NASA in 1969, they needed a source of power, not to fire the rock. The rock was fired using liquid hydrogen, but a source of power in the space to provide electricity for the space shuttle, to provide drinking water for the astronauts, and so on. And actually what they used was a hydrogen fuel cell, 1969. And this was the first time a man landed in the moon. And this is a real picture of the fuel cell that was used on the space shuttle. Okay. Another application of hydrogen fuel cells for long distances is actually for submarines. This is a Type 212 submarine that belongs to that is operated by both the German and the Italian Navy. And it runs on fuel cells since they can cross long distances without the need of charging. And usually submarines can stay up to 2 to 3 months in the sea. Then you cannot use a battery. And a fuel cell would be a perfect match for you. This is Boeing's fuel cell demonstrator airplane that was developed in 2008 just for demonstration, and they tried it and it flied. So you can run airplanes or at least a secondary auxiliary power generation system in your airplane based on fuel cells. So basically your gas turbines would provide for you the power just to take off and to land, while you are flying, while you are cruising, you can use fuel cells to provide the electricity needed by the airplane and so on. And that's what Boeing demonstrated actually. Finally, maybe you all heard about Nikola. Nikola gonna be the first ever hydrogen fuel cell truck to be produced. It's in collaboration with General Electric Motors, the famous US company, and already US Express Postal Services, البريد, signed a contract with Nikola to provide them with trucks, hydrogen fuel cell trucks, to basically deliver and transport the mail between cities in the US, since these trucks cross hundreds of miles every day between cities and states. then fuel cells would be a perfect match for such an application. طيب, we just discussed the good things about fuel cells and how things are, the sky looks blue and bright, but actually, as usual, there are some challenges. And I want to end my presentation with some of these challenges. And basically, the first challenge is actually what's called dynamic wireless electric vehicle charging system. And what is going on here is that you have a battery car like Tesla, and as it moves, there would be under the asphalt electric coils that would actually electromagnetically charge your battery car as it moves dynamically. So no need to like stop and charge your battery car and so on. And already Paris and London tried these technologies for a 100-meter lane on the highway, and it worked well. So the point is here that currently there are new technologies on how to charge batteries fast and dynamically. And if such technology succeeded, then at least for fuel cell electric vehicles, for sedan cars, it's gonna be a game changer. They won't be profitable anymore. Everyone will just go with a Tesla. Another thing, a Tesla requires a villa. Since you need to charge your Tesla, then you need to have a private garage to charge your Tesla in. If you live in an apartment, you cannot have an electric car, and you don't have a private parking, a private garage where you can charge your Tesla. Okay? On the other hand, charging battery cars takes a lot of time. With the standard charging system, the standard one, which like 95% of people who own a Tesla takes around 6 hours to charge. So it takes around 6 hours to charge your Tesla from 10 to 90%, while with the supercharger, it takes between 30 to 170 minutes. But the problem with superchargers is that they don't exist a lot around the world, okay? So there is a big shortage of superchargers. So due to all of these reasons, now Aramco started its hydrogen initiative. Air Products built its first hydrogen plant in Jazan. Air Liquides built 3 hydrogen plants in Yanbu. KFUPM started its first hydrogen fuel station in DTV. I hope you all know this. And we started in KFUPM our renewable energy concentration, as well as our hydrogen mobility concentration. So that's all what I have for today. Thank you so much, and I hope I didn't spend too much time.
No.
Thank you.
Thank you, Dr. Wael, very much for enriching us. We have a question, and just to everyone else, if you have a question, you can either write it in the chat box or raise your hand, and we will give you the microphone. There's a question from Faisal Salah. He's asking that he read about geothermal energy, which is one of the renewable sources. By consuming a lot, will lead to generate some bad gases. What do you think, Doctor? Is that source a solution to the global warming?
I'm sorry, I couldn't hear you well. By consuming a lot, what?
Okay, by consuming a lot of that, which is the geothermal energy, it will lead to generate some bad gases. What do you think, Doctor? Is that source a solution to the global warming?
So actually, I do research in geothermal. I actually have a graduate student who does research on geothermal. And geothermal is actually a very interesting technology to study. It's not yet popular in Saudi Arabia. For one reason is that we don't know a lot about geothermal. We are actually submitting a proposal to King Abdullah city for atomic and renewable energy to do for them some research on exploring the potential of geothermal in Saudi Arabia. there are some spots in Saudi Arabia, especially in the western region, in Medina al-Munawwara and around it, two spots specifically, one that's called the Layth and the other is called the Harrat. And both have very good geothermal properties and characteristics. And you can actually just by drilling wells, shallow wells, so around like just by drilling 500 meters or maybe 1000 meter maximum, you can get water that is as hot as around 90 to 95 degrees Celsius. And then you can use this hot water to basically run what's called an absorption refrigeration cycle. And that would be used for air cooling. So it's like an AC, it's an air condition, but that runs not on electricity, but runs on hot water. And 50% of Saudi Arabia's electrical consumption goes for cooling, for air conditions. So if you found a way that is cheap, that is renewable, like geothermal, that can provide for you cooling, then that would be perfect. I'm not sure exactly what type of dangerous gases that would be produced from geothermal. I'm not sure. The only thing that I would think about is that you can produce CO2 if your hot water contains like 5%, or your steam, depends on the temperature, contains like 5% CO2, then you need to remove the CO2 and capture it at the surface facility. And that would be expensive. But we don't think that in Saudi Arabia we have such high CO2 concentration in our geothermal wells at all. So there is no worry about the environment at all. You just need to make sure that you re-inject your geothermal water back into your reservoir at a good temperature. Because basically reservoirs in Saudi Arabia are mostly carbonate. And if you injected CO2 at very low temperatures, the minerals at the subsurface reservoir will react with CO2 and it's gonna form precipitants like carbonate salts that would block basically your reservoirs and so on. Otherwise, no problems with this. Yeah.
Okay, thank you.
This answered the question.
Yeah, inshallah. There's another question from Nasser Al-Sharif. He's asking, why store energy in the form of compressed hydrogen? Why not use air, for example?
Yeah, this is actually a very good question. So what Nasser is talking about is compressed air energy storage. You can also have a liquefied air energy storage. You can also have a compressed CO2 energy storage and a compressed nitrogen energy storage. You can compress anything and store it, but usually right now the best option and the one commercial is compressed air. And there is actually only one plant worldwide that does this, and it's in the UK. This is a very interesting solution. The problem with this is the following. First of all, the round trip for compressed air energy storage isn't that high. Okay, so the round trip isn't this high. You lose a lot on the way of energy. So the round trip efficiency is a problem. The second thing is, and actually this is the main problem with compressed air energy storage, is that you cannot control thermal losses in your stored air. So basically, when you compress your air and store it, you can either store it under the ground or you're gonna store it in tanks. And basically with time, heat will be dissipated to the surroundings. And you're gonna lose some of your heat and the temperature of will drop, basically. The temperature of your compressed air will drop. And this is a problem now. So if somehow and there is a lot of research going on here, is that if you somehow invented a good energy storage material that would basically store thermal energy instead of storing air, that would store thermal energy, and then you use this thermal energy to heat up your air later before it enters the turbines to generate electricity, that would be good. Another reason is, another problem is compressed air energy storage, regardless of anything, is only good for large applications. So if you have a power plant that is producing like 200, 300, 500 megawatt of power, and you want to store large quantities of power, then yes, if you have the space, you can go with compressed air energy storage. It's interesting, it's simple, and this is very important. And we have a lot of experience with turbines and compressors. But for smaller applications, it will not be economic. Yeah.
Okay, thank you, Doctor. There is a question from Abdurrahman. He's saying, isn't Nikola being investigated for fraud? And GM has extended the negotiation till the report is addressed and discussed. Fraud report to 29 September 2020. My point from this argument is, are we really that close to hydrogen automobiles? If not, what are the main issues we should focus on from your perspective?
So, for the first part of the problem or the question is, yes, it is true that Nikola is being investigated for fraud. This is mainly because Nikola hired a lot of ex-Tesla employees. And Tesla is claiming that basically these employees transferred unclassified data or classified data actually to Nikola. But this is business, and if you see how giant companies deal with each other, and how companies are ready to basically destroy each other just for the sake of interest, this is not something that is new. Companies always sue each other. You can see what happens on annual basis between Apple and Samsung, for example. So this is fine, you know. Now the problem is how close we are to, or the question is how close we are to fuel cell electric vehicles. Actually, we already have a fuel cell electric vehicle. It is Toyota Mirai. So this vehicle already exists. So really, I guess the right question to ask is, how close are we to have a large distribution of fuel cell electric vehicles around the world? And I'm not sure. This would actually depend on how fast we would build hydrogen fuel stations. The more hydrogen fuel stations we build, the faster people will adopt and will buy fuel cell electric vehicles. But this is not only applicable to fuel cell electric vehicles, but also to Teslas. The more charging stations that Tesla build, the more people will buy Tesla. Till now, Tesla is not in the Saudi Arabian market, but the fuel cell electric vehicles are in the Saudi Arabian market. So really, it has to do with the infrastructure, both for battery electric vehicles and hydrogen cars. I expect that there will not be an infrastructure problem with hydrogen in Saudi Arabia. And alhamdulillah, we already have a lot of hydrogen production going on. So the whole thing is just to set the business and take an administrative decision from the government. There shouldn't be a big problem.
Okay, thank you, Doctor. Muhammad Abdel Jabbar is asking, From one of the slides, we saw that all renewable energy projects in Saudi Arabia are solar-based. Isn't there other efficient options here?
No, actually, there was Dumatil Jandal wind farm. There was Dumatil Jandal wind farm. It is a wind farm, and it's a pretty big wind farm. The problem, and there is already NEOM, which depends on hydrogen. The problem is that, or the main thing is not a problem. Saudi Arabia is one of the top 10 countries in the world with solar potential. Okay, I think it's ranked as the 6th best country in the world with potential for solar energy. So it makes sense that solar energy is the dominant, but still wind farms are being built, as well as hydrogen with it for energy storage. Geothermal, again, there is an interest, but there is lack of knowledge. So once we know more about Saudi Arabia's geothermal potential, I believe that the government will start working on digging up some of these geothermal wells and using them. Yeah.
Okay, thank you, Doctor. There is one question from Abdurrahman Qadir. He's asking, can you please mention the differences between renewable energy and hydrogen mobility concentration programs in KFUPM?
Yeah, this is actually a good point. So, okay. So basically, I hope that many of you recognize from the presentation that renewable energy and hydrogen mobility are very much connected to each other. You cannot have an efficient renewable energy system without hydrogen. And you cannot produce hydrogen in an environmentally friendly way without renewable energy. So they are very connected. And so I really understand why both concentrations might a little bit be confusing. In the renewable energy concentration, we concentrate more on the power generation aspect of renewable energy. So we take courses on renewable energy. This is more into producing power from renewable energy. A course on fuel cells for energy storage of renewable energy. Solar energy course where you study concentrated solar panels to basically use sunlight to heat fluids. And you take economics, energy economics. While in the hydrogen concentration, we concentrate more on what hydrogen does and not on power generation. So you take how to produce hydrogen from renewable energy. You don't go deep into the renewable energy technology. You just deal with the renewable energy as a tool. So we don't go deep there. We only care about the processes. We take a little bit of renewable, but not that much. Fuel cells, of course. Internal combustion engines, since you're gonna be talking about vehicles, you need to know how does conventional vehicles work, and also how to burn hydrogen efficiently. And you take a course on hydrogen and electricity infrastructure. So basically, we talked about hydrogen fuel stations. We talked about how to basically store hydrogen and transport it. All of these logistic stuff and how to connect all of that with the main electric grid is discussed here. So they are connected to each other, but here we focus on hydrogen, there we focus on renewable power. And yeah, that's it. I hope this was a little bit clear. If not, please send me an email and then we can discuss.
Okay, thank you so much, Dr. Wael, for taking the time and enrich us during this webinar. We learned many new things, many important things about renewable energy and hydrogen fuel cells. And we learned about the challenges facing this field here in Saudi Arabia. The Innovation Club thanks you, Dr. Wael.
You're welcome. Thank you so much for the invitation. Thank you.
I would like to also thank our attendees of this webinar. I hope the information provided to you during this session helped igniting your passion and gave you a motivation to learn more about this field and use these technologies in your future innovations, inshallah. Just to remind everyone, we are at the Innovation Club in KFUPM, happily providing consulting sessions in regard of your innovation or your idea for innovation with many experts from the university. You can reach us out through our email or social media account, which I posted in the chat box. Thank you all for your time, and sorry to take more than the agreed time, but thank you so much, and wish you all a great night.
Thank you. Good night.